Now this slide gives you an overview of the PEARL system as implemented for the FEUP experiment. So as you can see, this conceptual view does access from the PCs used by the remote students through internet or intranet, which are accessing our PXI system, which is the lab server, which is physically connected to the demo board. Now the PXI system is represented on this picture, and the board is actually represented here. Now a conceptual view or a graphical view of the board is on that one, on that image, and you can actually see that we have the three instruments connected to the board. There's a function generator connected to one of the inputs, one of the functional inputs and one of the test inputs, an oscilloscope which can give you feedback from the signal that is coming from one of the output pins and one of the test pins, and there is also the boundary scan controller controlling the test infrastructure. So the purpose of the experiment is actually try to see what's coming from that pin through the internal test infrastructure so that it's coming out of that pin. And for actually doing that, you need to understand the protocol which is actually done or performed through these 4 pins. And for that we use the interface that I'm going to show you. Okay, what we're going to do now is actually to see what is the FEUP experiment and the kind of user interface that the student gets when he first accessed our remote experiment. The students, when they reach this point, they're expected to know all the theoretical part when going through the WebCT system. So when they first see this kind of interface, they are supposed to be familiar with this kind of layout. So if you see on this left frame, this is what you normally see when you are looking into an oscilloscope. So there's no much to talk about the interface because it really looks like the front panel of one of these instruments. Now this is the oscilloscope display where you can see one of the waves being displayed there. So again, to save you the details of the experiment, we are now seeing just the output of the board. And what we want to do is running the appropriate commands through the hardware that the students are learning about in order to see on this red line here, which is right now just a straight line, see this same wave here appearing on the red line. Now for doing that, the student needs to understand the protocol of the hardware. So what it does next is actually to call another interface. Ricardo, can you actually pop up? Okay, thanks. Which is, it looks like an application that the student is supposed to be familiar with. So we provide this application to the student at the beginning of the course so he can actually run this application at his own PC. So this should be familiar to him. Right. Now the student using this other interface is supposed to control the 4 pins of the digital infrastructure. So right now Ricardo will actually type there the patterns that we need to actually get the experiment done. So Ricardo, if you don't mind. So this will take some few seconds, and while Ricardo is doing that, let me explain the following thing. If the student doesn't make all the necessary steps, if he fails, not even if it is a single bit, he won't get the exact result or the expected result. So we don't provide any other feedback than what the hardware gives. So, but in a way, this also resembles a natural situation on the lab. So where the student has his function generated, his oscilloscope, and his boundary scan controller. Having the instruments in front of him and the board, he will get the same feedback. Values coming from the boundary scan controller and what he sees on the oscilloscope. And also looking into the position of the buttons of each one of the instruments. So there's not much to be given in addition to this. Now, it's also to the purpose that the student has to develop in its own the skills to know what he has done wrong. And for that, he can actually see what were the patterns that he has sent to the board. So this provides some kind of feedback for him. Is it now done? Okay. So it's still being done at the moment. All the difference between instructions and data corresponds to different buttons on the interface. But again, as I told you before, the students are supposed to have used this before. The only difference is this is actually a remote control, while the other one will be a local control. If you press this button 5 times, according to the standards, and the board we have on the lab is compatible with the standards, there will be a reset of the board, meaning that the test infrastructure will be in such a state that is totally non-intrusive, right? He has already sent the first instruction. He's now going to send the date into in an internal register so that the board gets into a condition when, after entering the next instruction, it will complete the entire experiment. Okay? And now Ricardo is going to send the instruction. So all these minor actions are part of the experiment. Go for it. And here it is. If you see, the red line is now superimposed over imposed over the white one. So what I ask is, have you changed the oscilloscope? So please go to the oscilloscope and change the volt per divisions of the channel 1 so that you can actually see. The red line is now there. So if you put into 1 volt per division, okay, this will go on the top of the white one. So again, changing to 2 or 5 volts per division. So get a better view. Okay, you see the red line over there? Okay, now because we have this all light, you can see well, but on your screen it's quite nitty, it's quite easy to see. Now this completes the experiment. So reaching this state, the student will feel happy, as we will feel, because he has gone right through it. And for the moment, that's it. So thank you for your attention, and that's it.